Hi guys, I'm back with another arcade PCB repair. Today on the bench I got another Double Dragon PCB, which has some graphical glitches. This time it's not one of my boards, but a board from a nice YouTuber that sent it over to me for repair. It's a guy from France called Romain, and his YouTube channel is Mod in France, and he's doing some console modifications, etc. And he has some soldering skills, and he tried to fix the board, but it didn't go too well. I tried to give him some tips, but they didn't help either, so we agreed that he could send the board over to me and I could take a look at it. Hopefully I will be able to fix it. I don't know yet, but I thought I might also just as well make a video out of it. So as usual, we're going to try to troubleshoot the board step by step using our usual tools, schematics, and try to get behind the problem and fix it, of course. The first step, as always, is the visual inspection of the board, and well, that reveals that the board is in generally good shape. There are some missing capacitors, which doesn't really matter, very common with the Double Dragon board. There are some ICs which have been soldered out of the PCB and have been socketed. That's 4 ICs over here on the bottom board, and that might actually have to do with previous repair attempts, because I think this will be the area that will become relevant later on. But yes, overall the board is in good condition, no real damage done to it, no problems with corrosion or anything like that. Okay, and looking at the game when it's running, you can immediately see what the problem is. The graphical background of the game seems to be messed up, and the game is actually running. It's running fine, the sound is okay. You can actually see the characters, which are completely normal. Also the text overlays up here appear to be normal, but there seems to be something going on with the background graphics, like you could see just on this high score screen, where with a brown background, which would normally be just black. There is something funny going on up here on the house, where you can see some sort of text which is not supposed to be there. And here you have an area which looks completely scrambled. But over here you can also see that there's some regularity. You can see maybe that this background graphics probably consists of small tiles, because they are repeating themselves like over here. Everything actually consists of small tiles, which are I think 16 by 16 pixels large. And as a programmer back in the days when this game was made, you would have to construct the background graphics of such a game using those tiles, and you were not able to just, take an image file and put it in the background of the game. And the reason for that, of course, is that making a predefined set of tiles and using a tile map to generate the background graphics, which you would use much less memory space, and therefore would be better suited for the RAM chips and EEPROM chips and the capacities that were available in those days. And considering that architecture, you can see that there's actually probably at least two problems with the background graphics, because firstly, the colors seem to be wrong pretty much everywhere on the screen. So in some areas the background graphics are even recognizable, like you can recognize this garage here partly, you can recognize this wall, you can recognize maybe the skyscrapers up here, but the colors are wrong. And in other areas of the screen you can see that there's probably been the wrong tile has been selected for the location on the screen, like over here on the house, or here after this wall part, and also on the ground down here. So I would assume that we are probably facing not only one but several problems with the background circuitry. And here we are back at my trusty Double Dragon schematics. If you would have to construct a circuit that would draw the background for a game such as Double Dragon, it would actually be pretty easy. All you would probably need to have would be some sort of a RAM chip, which works as a buffer, which stores the tiles that are currently visible on the screen. This RAM chip is actually up here, and this RAM chip would have to be connected to the CPU, because the CPU would have to be able to update the RAM chip's data. If the game starts or if the screen is scrolling, the tile map would have to be able to change, so the background would be able to change. And also the RAM chip would need to be accessed by the counters for the current horizontal and vertical position on the screen, so that when the game is drawing the screen, there's no such thing as a screen buffer with a game like Double Dragon. It's all being done live. So the position of the cathode ray, actually, of the current pixel on the screen, would have to be fed into the RAM also, so that the RAM would output the tile that is supposed to show up in this specific location. And that's actually all what we can see on the screen here. Here's some multiplexing going on. It is switching the address lines between the CPU and the screen counters. The data lines are connected to those 4 buffers, which are then going up further in the schematics. And also there's another buffer which is used to connect the CPU's data lines to the data lines of the RAM, so that it can be programmed. So that all makes sense. A pretty simple circuit over here, actually. And well, there's just one other page regarding the background graphics, and that is this one. The data lines from the RAM are coming up here, and they are being fed into EEPROM chips, and those EEPROM chips contain the graphical data for the tiles, and they are being muxed together here, and what we get here is the actual color for the current pixel on the screen. So this is how the background graphics work schematic wise. And here's an image I created, which I used to remind myself what parts of the Double Dragon PCB actually do what. And we can here, this is an image of the bottom PCB of the game, and all the ICs up here, which are orange, and the ones that are marked purple over here, those ICs have something to do or are part of the background graphics circuit that we just had a look at. So this is actually the region on the PCB that we will have to investigate. And the RAM chip is located over here, and the EEPROM chips with the graphical data for the tiles are those four guys over here. Okay, so the very good question is, how do we go about the repair? How do we start? Where do we begin? Well, the first thing I had in mind when Romain actually sent me a picture of the non-working backgrounds was to suggest to him that he could, as a first step, check the EEPROM chips which hold the graphical data for the tiles, because the color representations of the tiles don't seem to be correct, so there could be a problem with one of the EEPROMs, which is pretty common. But he already removed all of the 4 EEPROM chips from the sockets and actually tested them in an EEPROM reader and compared them to the MAMES ROM database, and they turned out to be all working fine. And also the sockets appear to be in good condition. There's no corrosion or rust or anything, so I think we can skip this step and assume that those EEPROMs are actually okay. Next thing that we could actually right now do, or the next thing that I actually already kind of started, is probing around with a logic probe in the circuitry that is probably compromised, and look for any obvious problems like floating signals, like signals that appear to be stuck high or low. This is sometimes a bit difficult because there might be certain signal lines which are mostly high, mostly low, and with the graphics not being gone but rather being scrambled, probably pretty much all of the lines will be kind of wiggling. So it is a bit difficult in this situation to find a really good clue with the logic probe. But I actually had an idea when I thought about how to achieve like sort of a steady state with the background. So it would be easier to probe in the circuit if the background is, you know, full of colors, full of different tiles, and moving all the time. It will be difficult to figure something out. But well, I thought of something. Let me show you. That is, at the beginning of the game, when you boot the game, there's sort of a ROM test and RAM test going on, and what I did is I removed this socketed IC over here, which is a secondary PCB which handles the objects on the screen in the game, I think. And if it is removed and the primary CPU, which is this guy over here, can't talk to this guy, it will refuse to actually start the game. And that is normally not an advantage, of course, but in this case we are getting stuck on this screen where it displays this list, and on this screen we already see a graphical error because there's some sort of repeating tile. I don't know what it's actually supposed to be, some bit of a tree or something, which is taking up the whole background here, and normally this would actually be just black. So this is pretty much a steady state of of the problem that we're facing, because the whole screen contains one sort of tile, which is the wrong tile, and not much is moving around or anything. So we could actually now probe the circuit with a completely black background. There should not be much going on, and maybe it is easier to detect a problem like a stuck line or whatever this way. And yeah, as it turns out, it actually got much easier. For instance, with this with the RAM chip, when I'm probing the RAM chip, the address lines are all still wiggling, which makes sense because let me see, maybe, yeah, like here, which makes sense because the screen is still being drawn, so the horizontal vertical positions are fed into the RAM. That is all right. But all the data lines are pretty much stuck because, and that makes sense also, because all the tiles for the screen are identical and they are all the same value, so the RAM chip is actually outputting the same value all the time, and this value seems to be well, the data lines seem to be mostly low. So you can see here that, yeah, mostly low. But there's one line right here where the signal appears to be high. Here it's low. This one is high. So all the data lines are low. One data line is high. I don't know if that is meant to be really, because maybe if you would generate, you know, a set of tiles and you would start the first tile you would generate, or the first tile you would have in your collection would maybe be just one black tile. So if you wanted to fill the screen with a completely black background, you would use that first tile. It would be pretty obvious. So it could be that this line is actually stuck high, and to find out if that is the case, we could actually do a bit of a cheat, because I do have a second working Double Dragon board at hand. We could take the working lower board from that Double Dragon and replace it with this one, and then check the RAM chip for the RAM chip's data lines and see that if there's any difference. And maybe we are lucky. Let's see. Okay, I replaced the bottom board with a working one, and well, yeah, obviously the screen is now black, like it's supposed to be. And if I'm probing the RAM chip on the working board, I can see that all the data lines are constantly low. So there is a very interesting difference that we found between a non-working and a working version of this PCB in that single data line. Okay, switching back to the non-working PCB, the error returns, of course. And now we have to think about what could be the reason for one of the data lines being high all the time when it is not supposed to be. Well, actually two possibilities. Either the RAM on startup is being fed with wrong information, so it's being told that this line has to be high all the time for all the tiles on the screen, or it is actually being fed with the correct information and it is outputting the wrong data because the data lines of the chip are compromised. And both possibilities need to be considered, but something funny shows if we look at the data line again. You see that it's not only high, like this line here, which is high, but also you see that there's it's this one over here, that there's a small kind of wiggling in the signal going on. So I think that this signal is cannot be really a steady high signal. So it looks to me as if this chip would actually be the RAM chip itself would actually have to be compromised to output, if it outputs such a non-steady high signal. which it does at the moment all of the time, because it's not being written, the data lines are not being accessed by the CPU at the moment. So we could actually look at the signal line with an oscilloscope and check what this wiggling that we are noticing here is all about. Okay, so probing the signal line with the oscilloscope shows us that there's well, a not really steady signal with around 1.5, 1.6 volts coming out of that pin, which is of course not okay. So I think this proves that the RAM chip is bad, and the next thing would be to replace this chip, put a socket in, replace the chip, and see what parts of the graphical problems we might have fixed with that by then. I removed the RAM chip and I put a socket in, and turning on the game actually looks now like this. So the background is not black, but it's gray, but well, that's just for fun. It's without a working chip. I got a new RAM chip right here, so let's put this in and see what happens. So after putting a RAM chip in, the screen background is black. So actually the faulty textures already have been removed. So now, of course, we want to put the secondary CPU back in to get the game running again. Okay, I put the CPU back in. Background is black. Okay, and the dragon looks alright. That's, I think some parts here were missing before. Oh, much nicer, I would say. So is it all fixed? It seems like. Okay, so, well, forget my theory about multiple problems. The board was actually completely fine. Just the RAM chip had a stuck line. Okay, great. So, well, that was easier than I expected, but nevertheless, I hope you maybe learned something, you enjoyed the video, and if so, please leave a thumbs up, and if you have any questions, please leave a comment. I'm always trying to answer all your comments and questions, and if you want, you're of course invited to watch my other videos and join my channel. So thank you very much for your time.